Okay, today we're going to look at 8.2, which is adding and subtracting rational expressions. Um, and I know you guys can read this where it says this LCM of polynomials. So I'm just going to read this here where it says, just as with rational numbers in fractional form, to add or subtract two rational expressions that have unlike denominators, you must first find the least common denominator. And the least common denominator is going to be the least common multiple of the denominators. So I'm going to refer to that as LCM. So that least common multiple of two or more numbers or polynomials, you get it by factoring them, and it's going to contain each factor the greatest number of times that it appears. Okay, so for example, if I look at here, I have this 6 and this 9. If I factor out that 6 and 9, 6 is obviously a 2 and a 3, 9 is a 3 and a 3. So the LCM, that least common multiple, would be this 2, and then however many times I see the 3 the most, which would be twice. So multiplied all together, that means 18. That means both the smallest number that 9 and 6 go into would be 18, okay? When you're looking at polynomials, what you're going to do is you're going to factor them. So I'm going to take that and I'm going, okay, what factors of 2 add to negative 3? And that would be negative 2 and negative 1. So here's my factored form right here. And then I'm going to go to this denominator, and I see that I can take out a 2 from that. So I'm left with x squared minus 1. And then that can be factored even further because that's a difference of squares. So that would be x minus 1 times x plus 1. And then I have this 2. So that would be right here. And so the LCM, you have to include every single factor that you see. So I'm going to have this 2 right here, which was here. And I have this x minus 1. It was listed once in each, so I just write it once. I have this x minus 2 here, and then this x plus 1. And so that would be the least common multiple. Okay, so we're just going to practice in this first example here. Whoops. Let's see. How do I can't scroll for some reason. There we go. Okay. So we're going to just find the LCM to start of each set of polynomials. So I'm going to start with my coefficient. So we're going to break down this 6 to a 2 and a 3, and that can't be broken down anymore. And then 15, 5, and 3, and then 9, 3, and 3. So when you're thinking of the LCM, you're writing each factor you see. Okay, so I see a 2, I see a 5, and then I see a 3 here, a 3 here, a 3 here, but there's 2 3s here, so we have to write the 3 twice because you need the greatest number. So when I multiply those, 10 times 3 times 3 would be 90. So I know my least common multiple is going to be 90, and then I'm going to look at my variables, and I have to pull out the highest exponent variable that I see. So notice I have x's attached. The highest I see is an x squared. And then I'm going to go to my y's. And the highest I see is a y to the fourth. And so the LCM of this would be 90 x squared y to the fourth. Okay? If we look at part B, so now I have polynomials. So I'm going to start with this one, and I need to factor this. So the first thing I can do is take out a GCF of y squared, and that would give me y squared left plus 8y plus 15. And then I can factor that. So I'm looking for factors of 15 that are going to add to 8, and that's going to be positive 5 and positive 3. So in factored form, this would be y plus 5 times y plus 3, and then I have this y squared that I pulled out, okay? And then we're going to look over here, and this is just a trinomial, so I can, right now, there's no GCF, so I'm going to factor. So I'm looking for factors of negative 40 that add to negative 3, and that would be positive 5 and negative 8. So in factored form, this would be y minus 8 and y plus 5. So now, when I'm writing the LCM, I'm going to write all the factors I see. So I see a y squared, I see a y plus 5, I see a y plus 3, I see a y minus 8, and then this y plus 5 is already listed right here, so I don't have to write it again. And so the LCM of this is here. So there's my least common multiple. Okay, so let's move on here to the next page. Okay, so now we're going to look at adding and subtracting. And when we add and subtract, we have to have a common denominator. And you guys already know that. Now it's just going to get a little more complicated with our common denominators. So what I'm going to do is I'm looking at my denominators and I need to figure out what the LCM is of those. Okay, so this one's kind of easy because I have 2 and 1. 8 is 4 and 2, and then 4 breaks down 2 and 2. Okay, so the factors I see are just 2's. I need to write the most that I see, which is 2 times 2 times 2, which would be 8. And you probably could have done that because you know that a 2 and an 8 can both become an 8, right? And then we said, okay, we got to find our variables. I need to pick the greatest exponent. So I know I'm going to have an x cubed, and then I know I'm going to have a y squared. Okay, so there is my LCM. So what's going to happen is I'm going to go ahead and rewrite these fractions. So I have this 3y over 2x cubed, and I'm going to leave a space there. Plus, I have this 5z over 8xy squared, and I'm going to leave a space. And so what I'm trying to do is I'm trying to get these to have a denominator of this right here. I need both of them to have a denominator of 8x cubed y squared. So if you look at this, okay, so 2 times what is going to give me 8? 4. I already have an x cubed, so I don't need to do that. And then I just need to get my y squared. And I need to do the same thing to the top and the bottom. Okay, now I'm going to come over here to this side over here, and I need to get this to become an 8. It already is, so I don't need to multiply by anything. I have 1x, but I need it to be an x cubed. So I need to multiply by x squared to get it to become x cubed, because remember, when I multiply powers with the same base, I add my exponents. And then I already have a y squared here. So here's my y squared, it's already there, which is what I need it to be. So I just have to multiply by x squared, top and bottom. Once I do that, I'm going to multiply across the top. So I have 12, and then I have y times y squared is y cubed over 8x cubed y squared, which was the goal, right? There's the LCM right there, plus, and then I'm going to multiply. I have 5, and I'm just going to put my x squared first because in standard form, x would come first. And then over this 8x cubed y squared. And the way we're going to write that is we're going to write it. Our final answer is going to be as one fraction. So this is, I can't put those together because they're not alike. So I'm just going to write 12y cubed plus 5x squared z all over 8x cubed y squared. Because when I add or subtract fractions, once the denominator is the same, the denominator stays as is, and I add or subtract the top. Okay, so let's look at the next one. So on part B, here are my denominators. I need to find out what the LCM is of those. So let's break down. So 16 would be 4 and 4. Break down again, 2 and 2, 2 and 2, and 5 would be just 5 and 1. So I have 4 2's, and then I have this 5 right here. Okay, so when I multiply all those together, that's going to be 80. And then I need to go to my variables, and I need to pick, again, the biggest exponent variable that I see. So I have an a cubed, and then I have a b squared. All right, so this is going to be my LCM. That's what I need both of the denominators to become. So I'm going to, let me erase this here. Okay, so I'm going to go ahead and rewrite my fraction. So I have 3a squared over 16b squared. I'm going to leave a space because I need to get a new denominator there. Minus 8x over 5a cubed b times, and I'm going to leave a space. Okay? So again, remember the goal is to get these over. The denominator will be 80a cubed b squared. That's what we're trying to get to. So 16 times what would give me 80? Well, that'd be a 5. I need an a cubed from my LCM, so I'm going to multiply by a cubed. And then this already has a b squared, which so does my LCM, so I don't need to multiply by anything else. So I'm just going to do 5a cubed on top. Then over here, 5 times what would be 80, and that would be 16. And then I have this a cubed, which already matches that a cubed. I have one b, but I need it to be a b squared, so I need to multiply by another b. So we're going to multiply by 16b top and bottom. Just as a reminder, this is subtraction, so that means it's going in with that 8x right there. Okay, so when I multiply across, I'm going to have 15, and that would give me a to the 5th, because remember, I'm adding the exponents. And then that's going to be a negative 8x times 16b, which would be a negative 128xb, or really you could write that, or should write it bx, but that's okay if you don't. I can't combine anything because those aren't alike, and so there is my final answer. Okay, now we're going to look at what happens when we have polynomial denominators. Okay, so let's, before we can find the LCM, we need to factor them out first. So we're going to start with this denominator here, and I could factor out a 6, and I'd be left with x minus 3. And then second side, I could pull out a 4, and we'd be left with x squared, or sorry, not a 4, what am I doing? That would be a 2, we can take out a 2, and we'd be left with 2x squared minus 7x plus 3. And now we're going to factor this trinomial. So we're looking for factors of 6 that add to negative 7, and that would be a negative 6 and a negative 1. And so remember, I taught you to factor by doing grouping, and I'm not going to do all the steps for that. You can pause the video and do all your work, but when you're done, you should be left with 2x minus 1 times the quantity x minus 3, and then I have this 2 here. Okay, so our LCM would be, so notice I have a 6 and a 2. So can a 2 and a 6, and I'm going to go ahead and mark this stuff out. Can a 2 and a 6 both become a 6? Yes, so 6 is the least common multiple. And if you're not sure about that, this would be factored as a 2 and a 3. And this is just a 2 and a 1, right? It's just a 2. So 2 times 3 is 6. And then I'm going to write my x minus 3, my 2x minus 1, and then I already have that x minus 3 written, so I don't need to rewrite it. Okay, so that's going to be my least common multiple. Okay, so what we're going to do is we're going to rewrite our problem, and I'm going to do it, and you're going to rewrite it with your factored form. So this 6 times x minus 3, and then times, and we're going to leave that space, right? And then we have this minus sign, x minus 1 over 2 times 2x minus 1 times x minus 3, and then I'm going to leave another space here. Okay, so I am going, all right, so here's my LCM right here, and that's what I need my denominator to become. So I'm going, all right, 6 times what is 6? Well, 1, so I don't need to multiply by anything. I have an x minus 3 already here. The only other thing I need is this 2x minus 1. So I'm going to multiply by 2x minus 1, top and bottom. Okay? And then I'm going to go over here, and I have this 2. I need it to become a 6, so I need to multiply by 3. And then I have 2x minus 1 here, which matches what my LCM needs to be. And I have x minus 3 here, which matches here. And so I don't have to multiply by anything else, just my 3 top and bottom. Okay, so now we're going to multiply. Remember that this is a binomial, so I need to take this in 2 times. So on top I have 10x and then minus 5, okay? And then remember, this is subtraction, so I need to take this negative through, and this is a binomial, into both of these. So this is really a negative x and a positive 1. So when I take this 3 through, I'm going to get a negative 3x and then a positive 3. And then on bottom, remember my denominator is going to be that whatever that LCM was that we were trying to get, 6 times x minus 3 times 2x minus 1. And you can see that that actually is what you get for your denominator for both. And after that, I'm just going to combine like terms. So 10x minus 3x would be 7x. And negative 5 plus 3 would be negative 2. And then I'm going to write my denominator. And everything should be simplified. And we are done. And there's our answer. Okay, so let's look at 3b. So 3b here, if I start with this denominator, there is no GCF to take out. So I'm just going to immediately start to factor. So I'm looking for factors of 20 that add to 21, and that would be a positive 20 and a positive 1. Again, you would do this by grouping, so you could pause this and do that and make sure you get this, but I'm going to write what it should be when you're done, and that's 4x plus 1 times x plus 5. And then I'm going to mark that out. And then I'm going to go over here to my other denominator, and the GCF is a 3, so we're going to take that out, and that would be 4x plus 1. So now we're going to decide on our LCM. So I only have one coefficient this time, so I just need to write that down. And then I'm going to write the factors I found, which was 4x plus 1, and then x plus 5. And then over on this side, I already have that 4x plus 1 written, so I don't have to write it again. You only would write it twice if it would appear twice on one of the denominators. So you're just looking at the factors of single denominators when you're writing the factors. Okay, so here is our LCM. So we're going to start off, and we're going to rewrite this problem. So we have this x minus 8 over 4x plus 1 times x plus 5, and we're going to take that times something. And then I have plus 6 over 3 times 4x plus 1, and then we're going to take that times something. Okay, so if you look here at my denominator, 4x plus 1 and x plus 5, I'm close. The only thing I'm missing is this 3. So I just need to multiply the top and the bottom by a 3 here. And then over on this side, I have the 3, that matches. I have the 4x plus 1. I still need this x plus 5. So I'm going to multiply by the x plus 5, top and bottom. Recall that this is a binomial, so I'm going to distribute this through. So that's going to give me 3x minus 24. And then over on this side, this is a binomial, so I'm going to multiply through to both, and that's a positive. This is a plus, so that's positive. Positive 6x plus 30. And then over my denominator is my LCM. What's happening? I'm frozen for some reason. What are you doing? Hopefully my pen didn't die. If it did, I might have to use my finger, and that will be terrible. Hold on. Okay, let's see if I can get it to work now. There we go. Okay, and then my denominator would be this 3 times 4x plus 1 times x plus 5. And then final step, I'm just going to combine like terms. So 3x and 6x would be 9x. And negative 24 and positive 30 would be plus 6. Then I have this denominator. And then the last thing we're going to do is just make sure that it's simplified all the way. So if you look here at the top, that has a GCF of a 3, and that matters because I have this 3 sitting out here. So if I take out a 3, I would be left with this 3x plus 2, and then I can cancel those 3's top and bottom. So my final answer would be 3x plus 2 over 4x plus 1 times x plus 5, and that would be my answer in simplest form. Okay, we are going to look now at complex fractions. So the last page. So having complex fractions with different denominators. Okay, so what's going to happen is I'm just going to look at these separately. So I'm going to look at the top first, okay? And so if you look at the top, this is like 1 over 1, right? So the LCM of the top is just the only factor I have, which is just this x. Whoa, try that again. Okay, so I don't need to multiply anything over here on the right, but over here on the left, I need to multiply by x over x. So that's going to give me, when I multiply across the top, x over x plus 1 over x, okay? And over, and then I'm going to look down here at the bottom. So if you look at the bottom denominator, the LCM is just the only factor that's there, and that's the y. So I don't have to multiply anything on the right. I'm just going to multiply by y over y here. So I have y over y minus x over y, okay? And we're just going to write this as one fraction now on top. So that's just x plus 1 over x. Once the denominator is the same, I can write it as 1. And then over, and then I have y minus x over y, okay? So once I get there, once I just have one fraction over one fraction, then I can rewrite this, keep the top one, change division to multiplication, and then flip the other one. Okay? And if there's anything that I can cancel top and bottom, we would. There's nothing I can do because this is a binomial and this one's a binomial. And so I can't cancel with just the monomials. And then those are different letters. So I can't do anything there. So we're just going to multiply across the top and multiply across the bottom. Okay, so this is a binomial that I'm going to multiply. So that's going to be xy plus y over, and then this is a binomial, xy minus x squared. Okay. And this is going to be my answer for that one. Okay, so if you look at 4b, so again, I'm trying to get this top right here to just become one fraction. So I need to get the denominators to be the same. And so if you notice, that least common multiple is going to be the c and the d. I need it to be a c and a d. So this side, I need to multiply by c over c. This side, I'm going to multiply by d over d. Okay? So I'm going to have on the top, this is c squared over cd minus d squared over cd. And then that just becomes c squared minus d squared over cd. Okay? If you look at this other fraction, this is like 2 over 1. So the LCM of this is just this factor c. I don't have to do anything to the left side. I'm just going to multiply the top by c over c.
Oh.
Okay, shh. So that becomes, my pen isn't working again.
Okay.
Grace, shh. I'm doing a video. Okay. Okay, so that becomes, on the top, and here's my little bar here, I just have d over c plus, and then I multiply 2c over c. And as one fraction, that's just d plus 2c over c. And then here's that bar. So once I'm left with one fraction over one fraction, I'm going to do keep it, change it, flip it. So keep the top as is, change division to multiplication, flip the other fraction. And then we're going to start canceling where we can. First, this is a difference of squares, so you can write that as c minus d times c plus d. And I'm going to, then I'm going to notice here that this c and this c can be canceled out. And here's what I would say about this. If you notice, it does become a difference of squares, but there's nothing that I can cancel with it. So since there's nothing I can cancel with it, I'm going to end up just marking that out. And then once I'm done, I'm just going to multiply across the top and multiply across the bottom. So I'm going to have c squared minus d squared over, did I do something wrong? Over d squared plus 2cd. Okay. And just as a reminder, you can't cancel this d squared and this d squared because they are married to their top, married to the bottom. And so that is going to be my final answer. Okay? All right, so let's look at two more of this. And we'll look at 5a. Then I'm hoping 5b maybe you can do on your own. Okay, so let's look at the top. So if you notice on 5a, the top, so this is, I'm going to make this one a fraction. I know the LCM is x because it's my only factor. So I just need to multiply this by x over x. Okay, so that's going to become x plus 2 over x. And then on the bottom, my LCM is going to be an xy because those are my two factors, x and y. So I have to multiply this by y over y and this by x over x to get them to be the same. So that's going to be 3x minus 4y over xy. So I just went ahead and skipped a step and made them already one fraction. Now that I'm there, I'm going to keep it, keep the top, change to multiplication, and then I'm going to flip. And then we're going to cancel where we can, and I can cancel those x's out. Whoops. Sorry, my pen is dying again. Okay, so I'm going to cancel out those x's, top and bottom, and there's nothing else I can cancel, so now I'm just going to multiply across the top and multiply across the bottom. That's a binomial. So this would be xy plus 2y over 3x minus 4y. And that would be my final answer. Okay, let's look at 5b. So 5b, if you look at the top, the LCM would be c and d. Those are my two factors. So I have to multiply this one by d over d and multiply this one by c over c. So that would become c minus d squared over cd. And then on the bottom, The LCM would just be C, because that's my only factor. So I'm going to multiply by C over C. So this would be 1 plus 6C over C. And then once I have two fractions, I'm going to keep the top as is, change division to multiplication, flip the bottom. And then where I can cancel, I will. So I can cancel those C's right there. And I can do that because this CD right here is not a binomial, that's a monomial. So I can cancel things that are the same when it's a monomial. And then I'm going to multiply across the top and multiply across the bottom, and that is a binomial. So I have C minus D squared over D plus 6CD, and that would be my final answer. Now, if you notice here on the bottom, they do have a D in common, but taking the D out doesn't allow you to cancel anything out. So that's why on the other one we were able to cancel something out with that GCF because it has something in common, top and bottom. Okay, so that is the conclusion of your 8.2 notes. Your homework assignment is on the next page that you can see. It should be attached to your notes. So you're doing like multiples of 3 and then multiples of 3. And I will end up posting the solutions so that you guys can see what you're doing. And if you have any questions, you can ask me. Feel free to message me and let me know. Okay, thanks for watching.